So today we will be reviewing the chapter 7 of the CNA1, the IP addressing. So this chapter examines in detail the structure of IP address and their application to the construction and testing of IP networks and subnetworks. So let's see for class activity. So IP for addresses. So what is it? Okay. So IPv for addresses. So it is okay. So it can be converted to binary. So initially it is a binary number. Okay. So we have 32 bits and it has 4 sections, and these 4 sections is called octets. So it consists of 8 bits. Okay, 8 bits of binary numbers. So 1 and 0. Okay, is it 1 and 0? Can also be on decimal form. Okay. Dotted decimals, octets, and 32-bit address. So converting by okay. So this is just for converting binary to decimal. So let's see. So just for example, we have just need to skip this topics. So just conversion of binary to decimal. Okay. For example, we have this. Okay, in this binary, so 101101, so we need to convert this to decimal. So we call this. So we have the positional value. Okay. So this is the position value 0, 1, 2, 3, 4, and 5. So you just need to set that as the exponent. So for example, 2 is to okay, this is the positional value. Okay. So 0, the exponent, because the radix is 2. Let's see. So this is for the decimal. So 2 raised to 0, raised to 1, 2, 3, 4. So 2 raised to 0 is 1, then 2, 4, 8, 16, and 32. So we just need to add the values which have the ones. For example, we have 1 plus 2, 4, so we have 5 plus 8 is 13 plus where 8, 16, 32. So 13 plus 32 is we have 45. Okay, so this decimal value here is 45 in decimal value. Okay. For example, we have this bit, but we just need to add this the positional value. So 2, 4, 6 plus 1 to 8 is 1, 3, 4. Okay. Just for decimal to binary. Okay. So in converting decimal to binary, so this is, for example, we have this 45. So we just need to get the remainder of every division we made. So for example, we have 45 divided by 2. So it equals to 22. Remainder 1. Okay. So let's remainder 1. Next is 22 divided by 2 is equals to 11. Is 0. 11 divided by 2 equals to 5. So remainder 1. Then 5 divided by 2 is equals to 2. Remainder 1. Then 2 divided by 2 is equals to 1. 0. Remainder 0. Then 1 divided by 2 is equals to 0. Remainder 1. So as you can see, we can write this remainders to binary numbers. So we have 1, 0, 1, 1, 0, 1. Okay. So in IP address, we also have the network and host portion. So in a 32-bit address. So in this example, you have this 192.168.10, the network portion, and the 10 as the host portion. So we have the subnet mask for determining the network portion. Okay. We use the subnet mask. So the subnet mask just identifies the number of bits as the network portion, and then the remaining bits would be the host portion of the IPv4 address. Okay. So the subnet mask here is /24, so meaning 4 bits from the left would be the network portion. Okay. Okay, the network portion is odd ones. So once it reaches 0, so it would be the host portion. Okay. So logical end, so just comparing the bits. So for 1 and 1, we have 1, 1, 0, and or 0, 1, or 0, 0. So would be 0. Okay. This is used for determining the network address or network portion. Just to see this. Okay. So we have the IP address in binary and subnet mask also in binary, and we just compare the binaries to each binaries. Then we can, the result would be the network address. We can obtain the network address. So activity ending to determine the network address. Okay, network address in binary. So we have 1, 0, 1, 0, 1, 1, 0, 0. Then 0, 0, 0. 1, 1, 0, 0. Then 0, 1. All zeros. We have /26. No, /23. /23. It should be this. It's 254/23. So our network address in decimal is 172 24 0 check. /23. /23. Oh. So I think it holds 510 addresses. So this is just the prefix lengths. So we have the /8, subnet mask 255, then the 32-bit address. So the prefix length is just the number of ones in the 32-bit address. We have this one, 2/30, 225, 252. network host, broadcast address. So network host address, it contains the first host address, the first host in the network, then the last host address, and the broadcast. So the unbroadcast address, the host portion is all ones. This, okay. So in /24 we have .1, then .254 and .2554 broadcast. Last host. The network address is all ones in the host portions. The host address, okay. So this is unique in the network. First host address, okay. This is the first host in the network, in the local network, then the last host and the broadcast. So at all once. So all the nodes in the network would be receiving the messages. So static IPv4 address assignment to the host. Okay, just we manually configuring the IP addresses to a device. So dynamic IPv4 address is we use the DHCP. We'll use the dynamic host configuration protocol for assigning IPv4 addresses automatically. So it provides IPv4 address, subnet mask, default gateway, and other configuration informations. Okay, so in IPv4 communication, so it can communicate with other devices in three ways: so unicast, broadcast, and multicast. Unicast is, so it's a one-to-one communication. Broadcast is one-to-all, and multicast is one-to a specific group in a network. Broadcast, okay, so it's a multicast. So it's just some of the devices can receive the messages. So unicast transmission, okay. What is this? Okay, we have the source destination. We use the source destination, the source address as the source IP address of the sending host, and then the destination address is the IP address of the receiving host. So for broadcast transmission, we have all ones in the host portion. So all the nodes in the area will be receiving the messages. So multicast transmission, so I think we have the range for multicast addresses. We have 224.0.0.2 So it's reserved for multicasting on local area network. It's a multicast transmission. Okay. Unicast. Okay. Public and private IPv4 address. Okay. We have public IPv4 address. So these are the addresses that can be routed on the internet. And the private addresses is these are the address that we use on our local network. So we have private address blocks. So we have this 10.0.0/8, the 172.16, that's 12, and 192.168.0/16. So all of this, the addresses within this range are considered private addresses. So we use the NAT or network address translation to translate our private addresses to public addresses. Okay, so in a local area network, we use the same public addresses. Password block, IPv4 address. So, okay. Start. Pass. Pass. That's it. Start. Pass. 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 Special user IPv4 address. Okay, we have the loopback addresses. So it is the addresses used by a host to direct traffic to itself. We also have the link local addresses. Okay, we have link local addresses for IPv4. Okay. This is peer-to-peer connection. 169. Okay, we have the API now. So they are used by Windows DHCP client to self-configure in the event that there are no DHCP servers available. Okay. So we also have the testnet. It's used for teaching and learning purposes. So that is the API pala. Okay, link local addresses for IPv4. Okay, we also have the legacy classful addressing. So how the class A. Okay. So have this class A specifics, the address blocks. So this is the range for class A. So it's /8. Okay. Maximum number of networks we have 128. And then number of hosts per network we have over 16 million. So the okay, so it's based on the bits on the IPv4 address. So you have the 0 as the first address. So when converted, so these are the range for the addresses. When the 32-bit address is starting with 0. So when starting with 1, we have the class B address. So these are the range for that class B block. So the default subnet mask is /16. So number of networks and number of hosts per network. So it's extremely large. We also have the class C. So the high order bit is we have 110. So the ranges for these addresses are in this one. So 192 to this 223 block. So the default subnet mask is 24. So the maximum number of networks is over 2 million, and the number of hosts per network is 254. I think this is the most common used type of network. So it's a class C. So video demonstration. Let's keep this classless addressing. So I think the classless addressing is okay. So because when using the classful addressing, so there are many addresses that goes to waste. So we use the classless addressing. Okay. So we use different subnets. So just to save addresses. So assignment of IP address. Okay, we have different organizations for that manages and maintains IP addresses. Okay. Skip this. Public or private IPv4 address. Okay. 172.16. We have private 209. I think this is public. This is lab. The need for IPv6. Okay. So because the IPv4 address is very limited, so we need IPv6. Let's see if there is. Okay. I think we don't use the NAT when using IPv6. Okay. We also have the enhancements for IPv6. No? IPv4v6 systems. Okay. So because there's not a single date to move to IPv6 for the foreseeable future, both IPv4 and v6 will coexist. Okay. So we use IPv4 and v6. So the transition is expected to take years. So the migration techniques can be divided into 3 categories. We have the dual stack. So it allows IPv4 and v6 to coexist on the same network segment. So dual stack devices run both v4 and v6 protocol stacks simultaneously. So also have the tunneling. So transporting v6 packet over an v4 network. Okay, the v6 packet is encapsulated inside an v4 packet. v4 tunnel. v4 tunnel. Also have the translation. So allows v6 enabled devices to communicate with v4 enabled devices using a translation technique similar to NAT for v4. So just for communicating v6 and v4. IPv4 issues and solutions. Let's see. So 128-bit address. So we have the v6, v4. We have the translation, dual stack, and tunneling. v6 representation. Okay, so we have 128 bits. So this X here, so it represents 4 hexadecimal numbers or 16 binary digits. So total of 128 binary digits. Okay, so the preferred format is just conversion for hexadecimal. Here are the preferred formats. Okay, so we also have, so v6 address most commonly starts with 2 or 3. Okay, so we have this link local address. So it just shows us the preferred format for v6. So we use colons. So for colons for so we use colons. Let's see. Wait. You can't find the correct word. Never mind. Okay, the rule 1 is we need to omit the leading zeros. Okay, so you can see we have the 0, 0, 0. So it just simplifies it to 0. Okay, so all the leading zeros, we remove that. We also omit all 0 segments. So for example, we have here long segments of 0. So we just write the double columns. Segregate. Let's see. Sorry. Translate. What I mean is paghiwalayin. Separate. Okay, separate the excess. Okay. So omit leading zeros. You have 2, 1, 0. What? Okay, because we already answered this. Okay. So there's also answered. Okay. Okay, we have, but we need to skip this. Okay. So IPv6 address types. The address types for v6. Okay, we have the unicast. So this is the unique address of the interface on the device, the multicast. So used to send a single v6 packet to multiple destinations and any cast. So in any cast is our address can be assigned to multiple devices. So meaning multiple devices can have the same IPv6 address. Okay. So v6 prefix length. So this is the subnet. So like the subnet mask in v4, but we use the prefix length. So in prefix, so we have 64 bits. So I think this is the network portion. And the 64 bits is the interface ID or the host portion. So it is unique. The v6 unicast addresses. So we have the global unicast. So it is the routable address, so similar to public IPv4 address. The link local address is the v6 address within the local link, the local network. So it is not routable and unique local. V6 link local unicast address. Okay. So these are the addresses used for communicating with devices on the same link and only on that link. So it cannot be routed. Okay, it can also be dynamically configured or manually configured. Okay. So they are in this range. So commonly they are starting with FE80 address. FE80 hexadecimal. Okay. Identify types of IPv6 address. Let's see. Hurry up. So we have the unique, so global unicast, link local, 64 the same link local. Check. Structure of v6 global unicast. Okay, we have the global routing prefix. So like I said earlier, so most commonly range of the first sextet is 2 or 3. So it must come with 2 or 3 because it is predefined. So the address, the global routing prefix starts with 001. Or subnet ID. So it is a 16-bit. Then the subnet ID. So let's see, global routing prefix. So it's the network portion of the address. Let's see. For subnet ID, so used by an organization to identify subnets within itself. So I think it is more discussed on the chapter 8. The interface ID, so this is the host portion of v4 address. Okay. Static configuration. Okay. We have the command for configuring the v6. So on a router, we have the v6 address, the IPv6 address. So first we need to specify or access the interface of the router, and then IPv6 address, this keyword IPv6 address, and then you need to enter the v6 address. Then no shutdown for activating the interface. See, just need to copy this interface, gigabit internet 0/0. So IPv6 address, and now shutdown. Then interface gigabit net 0/1. Need to copy this IPv6 address. Then no shutdown. Then interface serial 0/00. IPv6 address. You have this one. So this is my shutdown. Okay. So this is my second time filming for chapter 7 because at first so we have 1 hour and 17 minutes recording, and honestly I did not read all first. So now we are prepared somehow. So dynamic configuration, so we use this Slack advertisement. So we have for Slack only. Okay. Slack. So routing solicitation is involved in this dynamic configuration. So the router solicitation, it is a message for okay. So these are the request message from the devices to the routers, to all IPv6 routers. Then router advertisement. So it provides addressing. So option 1 is Slack only. So this is the default addressing. So it provides prefix length, and default gateway information. So we also have the Slack and the HTTP6. So it is also a stateless addressing. But so the router provides information, but we need to get some other information from DNS addresses from such as DNS address from the HTTP server. But for the HTTP v6 only, so we have the HTTP server to provide all the information. So except for the default gateway, the router will provide the default gateway. So that's this one. Okay. So in Slack only, we don't have a server. So there is no one tracking what IPv6 address uses. So we don't have the server. For Slack and stateless, okay. So router solicitation. So that is just a device requesting for address, and then the router advertisement from the routers. Okay, DHCP solicit. Okay, this is for additional information. Okay, so they will obtain that on the server. So the stateful is the server will provide all the addresses. Okay, we also have the EUI64 process handling generated. So in Slack or Slack with stateless DHCP v6, so they only provide the prefix and prefix length. So the interface ID would be provided by the device itself. So we have the EUI process. So in a the interface ID is the 64-bit. They need the 64-bit interface ID. So in EUI 64 process, they use the MAC address of the device and then inserts another 16 bits on it. Okay. So the 16-bit is the FE, I think. So let's see. So we can also have randomly generated interface ID. Okay, this is the process of the EUI 64. So generating the interface ID. So first one, the MAC address of the device, then it will split it, the MAC address, convert it into binaries, and then insert the FFFE. So let's see what is the FFFE. Okay, so this is, I think this is default. Okay, so then flip the UL. Okay, so the 7th bit, so for example we have 0, so it will become 1, or 1 will become 0. So we'll just interchange it. So the reversed. Okay, the 7th bit of our address, no, our person local. Okay. And then okay, so that's it. So from our router advertisement message, so I have the network portion, our prefix, dynamic link local addresses. Okay, we also use the AUI 64 process for the link local addresses of the device. So it is dynamic configured, but as you can see, our link local address is very long. So normally we need to statically configure or manually configure our link local address. So static link local address, we just simplify it. Okay, that is so it's used to make easily recognizable as belong to router 1. So in configuring the link local address, so we need the IPv6 address, then the link local address, and link local keyword. So verifying IPv6 address configuration, we have show commands here. So like show interface, show IP interface brief. So it provides the MAC address, the link local address, and the global unicast address.
Siya po ang birthday boy.
You can also verify the v6 configuration through the routing table on the router. Okay, the show IPv6 route. So it will display the routing table. You can also ping the address, and then show command also. So show IPv6 interface brief. Show IPv6 route. So for routing table and ping, just need to ping this one. Oops. Oh no. What? Just need to copy this one. Paste. Okay. Packet tracer. Assigned IPv6 multiple address. Okay. So it's used to send single packet to one or more destination. So have the prefix FF00. So these are the range for multicast addresses for v6 addresses. So we have two types of v6 multicast address. We have the assigned multicast and solicited node multicast. So first, for assigned multicast, we have reserved multicast address for predefined groups. Okay. So assigned multicast address is a single address used to reach a group of devices running a common protocol services. So we have the FF2, two common v6 assigned multicast groups. So we have the FF02, one, this is the interface ID, so all nodes multicast groups. So all nodes or devices in the network. So okay, this is a multicast group that all v6 enabled devices join. So this is like the broadcast address, no? Same effect as broadcast address. So all the nodes for all routers multicast groups, so FF02 : 2. So this is for all the routers only. So it is most commonly used for router solicitation. So for all nodes multicast groups, so router advertisement. Solicited node. So the multicast address is map to the the MAC address, no? MAC address of the host. So it allows the Ethernet NIC to filter the frame by examining the destination MAC address without sending it to the V6 or lab identifying. So ICMP v4 and ICMP v6. So it's only the messaging protocol. So this is used for to provide feedback about issues related to processing of IP packets and not to make IP reliable. Okay, the most common to both v4 and v6 of ICMP, we have host confirmation, destination of service unreachable, time exceeded, exceeded, and route redirection. So for host confirmation is an ICMP message can be used. So the echo message is commonly used for pings, destination service unreachable. So we have, let's see. So receives packet that it cannot deliver, it can use an ICMP destination to notify the source that the destination or service is unreachable. Can also include a code that indicates why the packet could not be delivered. So we have 0, 1, 2, 3, net unreachable, host, protocol or port unreachable. We also have the time exceeded. So if our TTL value has decremented to 0. So we'll also use the ICMP to notify the source address. The source node. So router solicitation, router advertisement messages. Okay. So we also use the ICMP protocol for addressing so router advertisement and router solicitation. And also for messaging between V6 devices, we use the neighbor solicitation and neighbor advertisement. Okay. For neighbor solicitation, so the router, in this example, we have the router knows the IPv6 address of a device but doesn't know what is the MAC address of it. So they use the neighbor solicitation. Then for neighbor advertisement, it just sends its MAC address. And also the duplicate address detection. So whenever a device has obtained a v6 address, so they they send what is this, neighbor solicitation address. So to detect if there is a device that have the same v6 address, right? So the destination address is the IP address of the source or the sending. So if it gets a reply, then therefore the v6 address is not unique. So pinging testing the local stack. Okay, we use ping to determine the host or the destination host is operational. So ping the local loopback. So we're just testing our local testing the internal configuration of v4 and v6 on our local host. So we use the 127.0.0.1. So we ping that. Okay. So if it gets a reply, so our host has a operational it is operational, but doesn't mean that the configuration of or our configuration on the addresses such as IP addresses are correct. So we can also use ping to connect testing in the connectivity local networks. So the most common ping is the pinging the default gateway. You can also use the ping on testing connectivity to remote areas or remote network. So if we get a reply from the remote network, so it means we have a connection to that. So but most commonly they are not replying because of security issues. So trace route or trace route, so testing the path. So we use this for testing the path of our packets. So ping, so used to test connectivity with two hosts but does not provide information about the details of devices between the hosts. So we have tracert for tracert command in Windows. So it will just display the paths of the devices. So TTL or hop limit for V4 and V6. So it is used to determine the path for the devices. Okay, verifying. Okay, I think we're done. Skill integration challenge. Okay, we have skill integration for. Okay, I think we're done. Now we learned how to the conversion for for binary to decimal, the private addresses, DHCP, the need for V6, the unicast, multicast, and broadcast or anycast in V6, and the work of ICMP. I think that's it.